Okay, little review. Review with me a definition. We talked about a system of equations, right? What was that definition without looking back? Do you remember? Well, a system, you're on the right track. What's a system of linear equations? Remember, it was more than one line? Okay, and then the solution, Josh, was where the two lines do what? Meet. So, we're still talking about solving systems. So our end goal today, Luke, is to see where these two lines meet. Except no longer today, Grace, are we going to graph them. We're just going to try to do this algebraically. Because what if I said the answer to your graph, the answer to your solution, was way off the graph, and the answer was 20, 5. Is that going to fit on our normal graphs? No. Because our normal graphs, goes +6 to -6. They're kind of this little window. And so we're going to show in the next couple days and over this chapter is ways to solve equations that don't fall in that little perfect tiny window. 6 to -6 kind of thing. And so one of those methods is called the substitution method. And we're going to fill in these steps later at the bottom of the page. But look, I just want to kind of show you how to do these two problems. And then we're going to go back and kind of figure out what the steps are to go with it. So here's our two equations. Now we're not going to graph these. We're just going to try to solve them algebraically. Our first one says y equals 2x. And the second one says 7x minus y equals 15. Now whenever we think of y, I want you to think, oh, that equals 2x. So whenever you see the value y, I want you to think, oh, that equals 2x. So what does y equal? 2x. So as I think through this, I'm going to always remember y equals 2x. So here we go. We have this equation 7x minus y equals 15. Now I replace the y with the parentheses. And once again, what does y equal? 2x. So what do you think I'm going to replace that y value with? 2x. And here's our purpose. I replace it with 2x, and now I have an equation with only one kind of variable. No longer do I have y's and x's, I just have x's. Is this easy to solve? Very. 7x minus 2x obviously is 5x. To solve this out, Abby, what am I doing here? Yep. You just divide, okay? And obviously x equals 3. Now, we all know from what Josh told us at the beginning that the solution is a point. And a point has an x and a y. How much of the answer do I have? Half of it. How do you think I get the other half? Well, I have x. Yeah, plug it back in and let's find the y. Now, here's what we want to do. I'm going to plug it back into what I think is the easier equation to use. Would you say equation 1 is easier or equation 2 is easier to do? Luke? 1, I would agree. So I'm going to put a number 1 out there, signifying I'm using equation 1. Y equals 2 parentheses, and I stick in that parentheses the value 3 that Abby did for us. So it looks like my answer is y equals 6. So I'm going to box that x and box that y. Now my question is, I don't know if this is right or not. Now I'm pretty sure it's right because we did it together. But in other problems, the answers that could be decimals or fractions, and we want to have a way to make sure that we get it right. So Noah, what we're going to do is we're going to take this value of x and y and we're going to plug it back into the other equation. Why the other? Because I already used the first equation right here. So I'm going to go to the other equation. I'm going to write it down below, signifying with a little number 2 here. 7x minus y equals 15. And hopefully my numbers will work in this second equation. Now supposedly, what does x equal? 3. And what does y equal? 6. So that's 21 minus 6 equals 15. True or false? True. So what is my answer in parentheses? 3, 6. In this case, did it happen to fall in that nice, neat 6 to -6 graph? Yeah. But it's not always going to be there. But this one did. In this case, was the answer nice, neat numbers? No fractions, no decimal.
Yes.
How likely do you think that's going to be? Actually, it's actually normal.
because the book sets up problems to end up being nice, neat answers. So Kyle, if you get an answer that's a fraction, it's not saying it's wrong, but it's unusual. So just kind of think through the problem. Most of the times, the answers are going to be nice, neat answers. So when you get one that's a little off, a decimal or a fraction, question yourself. It's not that it's wrong, but it's possibly wrong. So, all right, second equation. Draw a line right down here, kind of divide and conquer. Y equals 2x plus 2. Y equals negative 3x plus 4. What does y equal? 2x plus 2. So anytime I see a y, I'm going to replace it with 2x plus 2. So here we go. We take our equation, and I replace this y with big parentheses. And in place of that y, what am I going to put? 2x plus 2. Good morning, Justin. So there it is. I replace this y, which I'll circle, with a 2x plus 2. Well, now I have an equation with just one kind of variable, just an x. So I need to try to figure out how to solve these. Abby and Josh did a nice job in the last one. Who can help me out with this one? I need to get these x's somehow together. Do you remember what to do there? Sam, Ryan, do you remember what to do? Would you like to move the 2x over here and make it negative, or move the negative over here and make it positive? What would be easier, do you think? Yeah, so let's do a plus 3x. I like that, Ryan, thank you. That gives me 5x plus 2 equals 4. From here, is it pretty simple? Someone talk me through this. Go ahead, Ailey.
Subtract 2.
Subtract 2, okay. 5x equals 2. Keep going.
And then you would divide 5.
Divide by 5. X equals 0.4. Now, I intentionally did this. I intentionally gave us a problem that's not nice and neat. Okay, just Zach, so we can experience what it's like when they don't turn out to be 3 and 6. So this was intentional, 0.4, 2/5 is 0.4. Now I need to find the value of y. So no, I take this value and I plug it back in. Would you like, no, I'm going to let you choose, it's not going to matter. Would you like to use the top equation to find y or the second equation? Now before you choose, whatever you choose, we're going to work it out, and then we're going to use the other equation to check it. So you choose, 1 or 2? 1, all right? So we're going to use equation 1. Y equals 2 parentheses plus 2. And in place of this spot where the x was, I'm going to stick what number? My 0.4. If you have a calculator, that might be helpful to get out. Y equals 0.8 plus 2. Y equals 2.8. Once again, my decimals here were intentional because I want to show you an example of problems that are not nice and neat. Noah chose equation 1 to solve it, so we're going to choose the other equation to check it. So I'm going to put a little number 2 here, and I'm going to write the other equation, negative 3x plus 4. And here we go, we're going to plug these in. 2.8 equals negative 3 parentheses plus 4, and in that parentheses I'm going to put the value of x, which was 0.4. So 2.8, help me here, negative 3 times 4, negative 1.2, is that right? So what is negative 1.2 plus 4? 2.8? So what does that tell us? Does 2.8 equal 2.8? You bet. So what does that tell us? Our answer is correct. That's our answer. Check. So we solve it. We solve for y and plug it back into the other one to check it. Now let's go up to the top and let's kind of figure out what our rules are. I'm going to go from the bottom up. What do you think our last thing that we do is in each thing?
Check.
Okay. We check our answer. Ooh, I can't spell this morning. In the other, I'm going to box that equation. Because if you use the first one to solve it, you check with the second one, or vice versa. Okay, that's our last step. What did we do in the first step of each problem? We replaced this y with the value of the other variable, right? So that's where we're going to substitute one value with the other equation. There's one value or variable. All right, step 2 was down here. We solve for that remaining variable. So step 2, we solve for the remaining variable. And step 3, we have x equals a number. What did we do with that x equals a number? We took it and plugged it in, right? So we plug the answer in to find the second variable. And then after that, that's where we're going to check. And we check it into the other equation. So these steps hopefully are kind of straightforward. First we substitute, plug it in and solve, plug that answer in and solve again, and then check in the other equation. Make sense?